All right, let's talk about something that affects all of us, medical tests. We're going to pull back the curtain and learn how to read the scorecard for these tests so you can really understand the story your own health data is telling you. So picture this. You get a test results and it comes back positive. Immediately, your mind is racing, right? Is this real? Could it be a mistake? Just how much can I trust this one piece of paper? Well, it's a huge question, and thankfully, there's a really smart way to figure out the answer. See, to figure that out, you can't just look at your own result. You have to zoom out and evaluate the test itself. And to do that, doctors and data scientists have some pretty powerful tools to grade how well a test actually performs out in the real world. And the first most important tool is something called a confusion matrix. I love that name because it literally shows us how often a test gets confused. You can think of it as the ultimate performance scorecard that just lays everything out in the open. So what is it? Honestly, it's just a simple table. It pits the test's predictions, what it thought was going on, against the ground truth, what actually happened. And by doing that, it sorts every single result into one of 4 buckets, giving us this crystal clear picture of a test's strengths and weaknesses. Okay, enough theory. Let's make this real. This is an actual confusion matrix from a model that was built to predict heart disease. We've got the model's predictions on one side and the actual reality, the ground truth, on the other. So let's break this down, square by square. First up, top left, we've got 111 true positives. These are the hits. The model said these people had heart disease, and it was absolutely right. This is exactly what you want a test to do. Bullseye. Now, bottom right, we have 146 true negatives. These are the correct rejections. The test correctly identified that these people did not have heart disease. Another big win. So that diagonal line from top left to bottom right, that shows you every single time the model got it right. But of course, no test is perfect. Now we get to the errors. Here we have 18 false positives. Think of these as the false alarms. The test screened disease, but the person was actually healthy. This is what we call a type 1 error, and it can cause a ton of unnecessary worry and more testing. And finally, we have these 28 false negatives, and these are the ones you really have to watch out for, the dangerous misses. The test said you're healthy, but the person actually had the disease. This is a type 2 error, and it's often the most serious kind because it can lead to someone not getting the treatment they need. Okay, so we've got these 4 numbers. The hits, the misses, the false alarms. Now, here's where it gets really cool, because we can use these numbers to answer the 2 biggest questions a patient is ever going to ask. I mean, these are the questions, aren't they? If you get a positive result, you need to know, what's the real chance I'm sick? And if it's negative, you want to know, how confident can I be that I'm in the clear? Well, statistics gives us the tools to calculate exactly that. So for that first question, we use something called positive predictive value, or PPV. It's just the probability that if you get a positive result, it's a true positive. And the formula is super simple. You just take the number of true positives, the hits, and divide it by the total number of positive predictions, which includes both the true hits and the false alarms. Let's plug in the numbers from our heart disease example. We take our 111 true positives, and we divide that by all the times the model said positive. That's 111 plus the 18 false positives. And what do we get? About 85%. So what that means is a positive test from this model gives you an 85% chance that you actually have heart disease. Now for the flip side, we calculate the negative predictive value, or NPV. This tells us the probability that a negative result is a true negative. And the formula is pretty much the same idea. You divide the true negatives by the total number of times the test said negative. So in our example, that's 146 correct rejections divided by the sum of those 146 plus the 28 dangerous misses. That works out to about 84%. So a negative result from this test means there's an 84% chance you are genuinely in the clear. But here's the thing. A test's performance isn't just about 1 or 2 static numbers. It's almost always a delicate balancing act. And there's a fantastic visual tool that shows us this trade-off perfectly. Just think about it for a second. If you design a test to be super sensitive so it catches every single sick person, you're probably going to end up with a lot of false alarms for healthy people. But if you make it really strict to avoid those false alarms, you risk missing some people who are actually sick. See, it's a trade-off. And this is where the ROC curve comes into play. It's a graph that brilliantly plots a test's performance across every possible setting. It gives you a complete visual snapshot of that trade-off between catching disease and accidentally flagging healthy folks. Now, rating one of these looks complicated, but it's not. The line going up is the true positive rate, how good it is at finding the disease. The line going across the bottom is the false positive rate, how often it makes false alarms. So, where do you want to be? The top left corner. That's the sweet spot. 100% hits, 0 false alarms. So the more your curve bows up towards that corner, the better the test is. And that dashed line in the middle, that's basically just a coin flip. So, we've looked at the scorecard, the key stats, the visual trade-offs, but let's get down to it. Why does any of this really matter? Well, it all boils down to one crucial thing: turning confusing data into confident decisions. Knowing this stuff empowers you. It gives you the language and the concepts to ask smarter questions, to really dig in and evaluate the evidence behind a diagnosis. It helps you move from just being a passive recipient of a result to being an active, informed partner in your own healthcare. And this isn't just about us as patients. This is at the very core of good medicine. For doctors and clinicians, this isn't optional, it's fundamental. Having a solid grasp of these basics is what empowers them to make better decisions that lead to better care and better outcomes for all of us. So I'll leave you with a question to think about. The next time you're faced with a medical test, what will you ask? Now that you know how to read the scorecard, you're ready to look past a simple positive or negative and start asking what those results really mean. Thanks for joining me.